Lengths of secants and tangents. So we're going to talk first about the secant segment theorem. States if two secants intersect the exterior of a circle, such as this picture we have to the right, notice that the secant lines are intersecting at point C, which is the exterior of the circle, then the product of the lengths of the secant segment and its external secant segment. So the length of the secant segments for this first one would be, of course, from here to here, so G to C. And the external secant segment would be this portion right here, H to C, is equal to the product of the length of the second secant segment and its external secant segment. So again, the length of the secant segment is N to C now, and the external portion would be right here, which is P to C. So the way that I like to look at this is in terms of the outside and the whole. So the external segment I call the outside. So this would be the outside. And what do I mean by outside? Outside the circle, of course. And then the whole is the entire secant line from N to the point where you're intersecting. So from the point where you intersect to the point that's on the circle over here. So if we write it in this terms, that means that the outside times the whole is equal to the outside times the whole. That's how I like to look at it, because again, it says the product of the length of the secant segment, which was again the GC times its external secant segment, which is HC. So GC times HC is equal to the product of the second one, so which is NC times PC. So it's hard when you read the definition, but when you actually look at the picture, it makes it a little bit easier. So again, you're always going to hear me say for the secant segments, outside times the whole equals the outside times the whole. So let's go ahead and practice this. So we're going to solve for x. So we have our secant lines. So for this, to solve for x, which is this entire length, we know that we have to multiply the outside times the whole equals the outside times the whole. So this is the whole. And this portion right here is the outside, which again was 2. So the outside times the whole equals the outside times the whole. So in this case, the outside is x times the, the whole is x times the outside. So I should do it the other way. So 2 times x is equal to the outside. So now be careful here, because for this second one, notice that they didn't add those for you. So you have to add the 8 plus the 14 to get the whole, which is 22. So the outside is 14, because that's this length right here, times the whole, it's 22. So we end up with 2x equals 14 times 22. So 2x is equal to 308 divided by 2, and x is equal to 154. All right, so let's go ahead and look at the next one. Same thing. So I'm going to highlight the outside portion first. So this is the outside for both of them. And then I'm going to highlight the whole. So the whole would be from here to here. So outside times whole is going to be equal to the outside times the whole. So the AB segment, the outside is 15 times the whole. So the whole, it looks like it's 15 plus x. equals the outside for AC is 12 and the whole is 12 plus 28, which is 40. So the AB again was equal to x plus 15 and AC was equal to 12 plus 28, which equals 40. So that's the whole for both of them. So when we solve, we would get 15 times 15, which is 225, plus 15x equals 12 times 40, which is 480. And then subtract 225. So we get 15x is equal to 255. Divide by 15. And we get x is equal to 17. So if I want to find the length of AB, AB is equal to x plus 15. So 17 plus 15, which equals 32. Go ahead and see if you can do question 4 on your own. When you're done, pause the video and we'll check your work. So for this one, the outside is 16 and the whole for AB is equal to 16 plus x plus 2. So that would be 18 plus x, or x plus 18. And then for the next one, we have, let's look at AC. The whole would be 10 plus x plus 20. So 30 plus x, or x plus 30. So that's the whole. And then the outside for this line is 10. So we have the outside for AB times the whole equals the outside for AC, which is 10, times the whole, which is x plus 30. So we want to distribute. So we get 16x plus 288 is equal to 10x plus 300. We'll subtract the 10x. It gives us 6x plus 288 is equal to 300. And subtract 288. So 6x equals 12. Divide by 6. And x is equal to 2. So then if we want to find AB, remember we said AB was x plus 18. So 2 plus 18 gives us 20. And if we want to solve for AC, remember we said that was x plus 30. So x plus 30, which means we get 2 plus 30, which is 32. And those are our solutions. All right, so the next theorem that we have, the secant tangent theorem, states if a tangent and a secant intersect in the exterior of a circle, so notice over here, this is the tangent line, and this is the secant line, and they intersect on the outside. So the outside intersection. Then it says the product of the lengths of the secant segments and its external segments are equal to the square of the length of the tangent segment. So the square of the tangent segment, so tangent squared is equal to the product of the, so the outside, so the external segment times the actual, like, so just like the one we did, so the outside times the whole. So again, this is the external secant, and the whole would be the entire line from here to here. So this is the, again, whole line, and this is the outside. And for the tangent, this is the segment that we are using. So in this case, the tangent segment, the outside equals the whole. So if you want, really, the tangent squared is just the same thing, outside times the whole, because it's the same thing. So if you want to use the same process we just did in the last one, that's okay. Outside times the whole equals outside times the whole. So that's for a tangent and the secant line. So if we look at this next example, we have the outside, and the whole would be from here to here. And this is the tangent line, which the outside and the whole are the same, which is x. So let's go ahead and use the tangent line. So the tangent squared would be outside times whole, so x squared is equal to the outside, so 4 times the whole. So remember, the whole is this entire line, which is 4 plus 12, which gives us, of course, 16. So 4 times 16. So just be careful not to do 4 times the 12. That was when we were doing the other theorem that we had the other day. So for this, we get x squared is equal to 64. And x is equal to plus or minus the square root of 64. So x is equal to plus or minus 8. But of course, we don't have a negative length. So that means that our solution is just x equals 8. Looking at the next one, same thing. So our tangent line is here, which is x. So tangent squared would be x squared. And then for the other line, our outside is the 10, and the whole would be the entire line from here to here. So we have to add those values together. 15 plus 10, which of course gives us 25. So the outside for the tangent, so tangent squared equals outside, which is 10 times the whole, 25. So x squared is equal to 250. So 250 is not a perfect square, so x is equal to plus or minus the square root of 250. So we're going to have to break this down. We know this is 25 times 10, and 25 breaks down into 5 and 5, and 10 breaks down into 2 times 5. So we only have one group that we can take out. So x is equal to plus or minus 5 times the square root of 10. So our answer would be 5 root 10. Of course, we don't use the negative answer. So why don't you go ahead and see if you can do this next one on your own. When you're done, on pause, and we'll check our work. So here we have the outside for both of them, and then the whole would be from here to here. So the tangent squared, so 15 squared equals the outside times the whole. So the outside is 5, and again, the whole would be x plus 5. So 15 squared is 225 is equal to 5x plus 25. So subtract 25. We get 200 is equal to 5x. Divide by 5, and x is equal to 40. So then we want to solve for AB, which is this length right here. So AB is equal to x plus 5. So 40 plus 5, of course, is 45. All right, so see if you can pause the video and do this next problem on your own. When you're done, on pause it to check your work. So for this next one, we have 2 secants, notice. So we're doing the outside times the whole. So here's the outside for both the lines. And the whole would be from here to here and here to here. So for the outside, we have x plus 2 for the first one, and the whole would be x plus 2 plus 2x minus 8. So when we combine like terms, we get 3x minus 6 equals the outside, which is x plus 1, times the whole, which is x plus 1 plus 2x minus 5. So that gives us 3x minus 4. So again, the outside times the whole equals the outside times the whole. So now we're going to have to FOIL out and combine like terms. So for the first one, we get 3x squared minus 6x plus 6x minus 12 is equal to 3x squared minus 4x plus 3x minus 4. So combining like terms, these cancel out. So 3x squared minus 12 is equal to 3x squared minus x minus 4. So for this one, we can combine terms on either side of our equal sign. So if I subtract 3x squared, notice that cancels out my quadratic term. I'm left with negative 12 equals negative x minus 4. So I don't have to worry about doing the quadratic formula to solve. If that quadratic term would not have canceled out, I would have set it equal to 0 and then use the quadratic formula if I had a quadratic equation. Add the 4, and we get negative 8 equals negative x, so x equals, of course, 8. So now that we have that, we want to find AB. So AB, remember, was equal to 3x minus 6. So that means we get 3 times 8 minus 6, which is 18. And then we want AC, which remember was 3x minus 4. So 3 times 8 minus 4, which gives us 20. Okay. And I think there's one last problem. So for this one, again, see if you can pause the video, and then when you're done, unpause to check your work. So for this one, we have a tangent times a secant. So the tangent squared, so the outside part is the 2x. So that's the tangent line. So tangent squared would be 2x squared. And then that's equal to the outside times the whole line. So the whole line, notice, would be from here to here. So x plus 2 plus 2x plus 5. And that gives us 3x plus 7. So 2x squared, the tangent squared, equals the outside of the other secant, which is x plus 2, times the whole, which we just said was 3x plus 7. So be careful, because here you're squaring the 2 as well. So 2 squared would be 4, and then x squared. So often students forget to square that 2 as well. So it helps you to write 2x times 2x to see, that's fine, equals, and here we have to FOIL. So we have 3x squared plus 7x plus 6x plus 14. And then we're going to combine like terms. 4x squared equals 3x squared plus 13x plus 14. And I don't like working with negative quadratic terms, so I'm going to subtract everything to the other side. So I have a quadratic, a constant, and a linear. So this gives me x squared equals 13x plus 14. And I'm going to take the 13 and the 14 to the other side with the x squared. So x squared minus 13x minus 14 equals 0. So for this, because it's a quadratic equation, I can either factor to solve or use the quadratic formula. Factoring is normally faster. So I'm going to go ahead and do find factors of 14 that add up to negative 13, which would be x minus 14 times x plus 1. Set your factors equal to 0 to solve. So we know we can't use the negative answer, so that means x equals 14. So if we want to find AB is, of course, 2x. So 2 times 14, which gives us 28. And then we want to find AC, which we said was 3x plus 7. So 3 times 14 plus 7, which gives us 49. And that is it for this lesson. So make sure you add these to your graphic organizer.